Okay, so we are going to continue from where we stopped yesterday. So in our yesterday's lesson, we have finished discussing all the objective and structure. So today we are going to continue with the essay questions. So let's begin. Okay, so essay question for chapter 6, number 1 sounds like this. Explain the observation of the reaction for each halide ions with aqueous silver nitrate, followed by dissolve in both concentrated and dilute ammonia aqueous solution, 7 marks here. So you should be able to explain observations. So every time when the questions give you the keywords, try your best to highlight them. You should explain and observe. Okay, so always come with, whenever you explain observation, 3 most important key points is number 1, you should be able to state the observation. Number 2, you should be able to write the chemical equation. Number 3, you should be able to explain what happens behind the equations there. Okay, so definitely you're going to come up with equation. So you start from Ag plus X minus if AgX, because these are very general equations that represents all chloride, bromide, and iodide. So AgCl is a white precipitate. Okay, so why is it a white precipitate? So it is dissolved readily in the concentrated dilute ammonia aqueous solution. I must mention both of them. Concentrated and diluted ammonia aqueous solution in order to form a complex of AgNH3 2Cls in here. Okay, so AgBr is a cream precipitate. Okay, so AgBr only dissolved in concentrated ammonia but not dilute solutions. And last but not least, silver iodide is a yellow precipitate that does not dissolve in ammonia aqueous solution. So in here, there's only 2 equations that you need to write. One is for the formation of the precipitate. Another one is the formation of the complex. Usually for this kind of the repeating equations, we usually give only 1 mark for each equations only. So however, if you feel insecure, you want to write all the equations, go ahead. Okay, just write whatever you can, because as an essay, as a student, when you're writing essay, you are trying to find more points to write in here. Okay, and then I also encourage you all to write in the explain. Okay, it is due to the formation of the complex AgNH3 2Cl, which is a colorless solution, for example. So you should also edit this. You can also present your answer in the form of tables. Okay, so what type of tables that I'm talking about, you can refer back to the notes that I've already explained earlier on. Okay, so with that, that is for how you answer for essay question number 1A. Okay, immediately we move to 1B. To fix a photography print, unreacted silver bromide on the paper is dissolved in the aqueous solution of sodium thiosulfate, Na2S2O3. Aqueous sodium thiosulfate also dissolved in silver chloride and silver iodide. So using this information and suitable equations and your answer in A, predict the relative strengths as ligand of thiosulfate, ions, water, and ammonia. Give your reasoning in here. Okay, so in here you should be able to in here you are trying to explain what happens when you added sodium thiosulfate to silver chloride and also silver iodide. Okay, so the relative strength of the ligand goes like this. So you have the SO2, which is the weakest, followed by SOO3, which is the strongest, followed by NH3, and followed by H2O is the weakest. Okay, so H2O is the weakest ligand among all of them. So because it is, therefore, it is not strong enough to displace the chloride ions inside the ligands, inside the silver chloride. Okay, whereas ammonia is a strong ligand enough to displace the Cl minus, but it cannot displace I minus. So this is the reason why when you try to add concentrated ammonia to this silver iodide, it cannot dissolve inside the silver iodide because it is not strong enough to overcome the ionic properties inside the silver iodide inside there. Okay. Yes, because ionic bond or ionic characteristic in AgI is very strong. Okay. And then last but not least, so thiosulfate is the strongest ligand since it can displace even the even the silver chloride. Okay, so that is how you are going to write. Is there any equations? Is that there? No. Okay, never mind. The equations inside there later I'll try to find out and write it for you. Okay, and then C, state and explain an application of silver bromide in the photography industry. So silver bromide is used to for black and white photography. It is used for black and white photography. So under the exposure of the ultraviolet, so silver bromide decomposed to silver and bromine according to the equations. So I forgot to write one more statement. White photography. Okay, so this is the usage of the silver bromide in here. Okay, so with that, that is how you are going to answer for essay question number 1. I know that the B in here sounds not very convincing because I didn't give you the equations inside here. So later I will try to find out, and then I'll put it on the comments part after I find out what is the equations behind all this. Okay. Okay, so that is for question number 1. Immediately, we are going to advance to question number 2. So question number 2 is, so chlorine possesses different chemical properties when react with sodium hydroxide under different conditions. Using suitable ionic equation and oxidation number, describe the reaction of chlorine when 1, react with sodium hydroxide in cold condition and the mixture is then heated. Then number 2, react with sodium hydroxide in a hot condition. Okay, so you need to explain what happens with using oxidation number, what is actually going on in here. So let's start from number 1. So when you react first with cold sodium hydroxide, so chlorine here undergoes this proportionation in cold sodium hydroxide. So according to the equation, Cl2 plus 2NaOH give NaOCl plus NaCl plus H2O. So the changes of oxidation state you also need to mention, when the oxidation state of the chlorine changes from 0 to +1 and -1. So in here, chlorine in here is 0, NaOCl in here is +1, Cl here is -1. Okay. Okay. Then what happened when further heated? So when further heated, it will further undergoes this proportionation, okay, where according to the equation, Na3 NaClO give to NaCl plus NaClO3. So the changes of oxidation state from +1 to become +5 and -1, where in here, as we mentioned just now, this one is +1, isn't it? So NaCl is -1, NaClO3 is +5. Okay, so this is what happened when heated, when the mixture is further heated strongly. Okay. Okay, so that is how you are going to explain when the chlorine react with sodium hydroxide in the cold condition, followed by when heated. Then we have number 2. What happened when react with sodium hydroxide in hot condition? So chlorine will straight away oxidize to the disproportionate or oxidize to the highest oxidation state it is possible, which is the +5. So the oxidation state changes in here from 0 to +5 and 1. Okay, so we already state disproportionation. So even if you write further disproportionation, there is no marks occurring here. Okay. Okay, so this is the changes of the oxidation state that happens when the chlorine is dissolved in hot sodium hydroxide here. Okay, so hopefully you'll be able to explain clearly when the right times comes. So these are the situations that you have to know on how to describe when you react with chlorine with cold NaOH followed by heating, and also react with hot NaOH followed by heating. Okay, so that is how you are going to solve for question number 2A. Then we are going to continue with question number 2B. Table below lists the melting point and boiling point of chlorine, bromine, iodine. Explain the trend of the melting point and boiling point of chlorine, bromine, iodine with regard to the structure and the bonding of this structure. And number 2, based on the information, describe the physical properties of chlorine, bromine, and iodine. Okay. So in here, you have to mention, of course, you have to first mention that chlorine, if possible, write out the formula. And if you want to add, you should also add that chlorine, bromine, and iodines are diatomic molecule naturally. Okay, so they are all simple covalent molecule whole by weak van der Waals forces. So as the melting point, boiling point increase from the chlorine to iodine as what? As the molecular mass or molecular size increase, therefore increase the strength of the weak van der Waals forces. Okay, so that is how you are going to explain the trend of the melting point, boiling point of chlorine. And then number two, you have to describe the physical properties under room temperature pressure. Okay, of course, they are referring to under room temperature pressure. Okay, so chlorine is a yellow greenish gas, okay, whereas bromine is a reddish brown liquid. Finally, iodine is a black solid in here. Okay, so that is how you are going to describe the physical properties of chlorine, bromine, and iodine. Okay, so very straightforward questions. So for each of the description, you get 1 mark here. Okay. Okay, so with that, that is how you are going to solve for essay question number 2. So we are going to have a look further at the essay question number 3. Iodine is one of the elements of the group 17 of the periodic table where iodine solution is applied in our daily life as antiseptic. Iodine is a weaker oxidizing agent compared to chlorine. So using suitable standard electrode potential value, compare and explain the reaction of chlorine and iodine with number 1, potassium bromide, and then number 2, iron 2 nitrate. So in here you have to explain, you have to compare for both of them, okay? Chlorine and also iodine with number 1, potassium bromide. So in here, chlorine can displace chlorine can use to displace the inert value of this one. Right? Okay, so usually when it comes to this kind of the questions, you should be able to provide all the correct information. Number 1 is the suitable equations. Number 2 is the overall equation, and then number 3, we are going to state that what happens if the inert value is positive and negative in here. Okay, so for example, you use the correct inert value, which is the Cl2 plus 3 minus give to Cl minus, inert is positive 1.36, and then bromine, bromide ion to become bromine, 2Br minus, if Bl2 plus 3 minus, inert is negative 1.07. So you write your overall equation, Cl2 plus 2Br minus, give Bl2 plus 2Cl minus, inert cell is positive 0.29. So you also have to mention when the inert cell is positive, the reaction is spontaneous, therefore chlorine can displace bromide ion. For the case of the iodine, so you use the suitable half equation where I2 plus 3 minus give to I minus. Excuse me. And then for the bromide ion, you still use the same half equation. So the overall equation is I2 plus 2Br minus give Bl2 plus 2I minus, where inert cell is equals to negative 0.53. Since inert cell is negative, reaction is non-spontaneous. Then for the case of the number 2, which is iron 2 nitrate, so chlorine when react with the iron 2, so when chlorine act as an oxidizing agent, so Fe2 plus act as a reducing agent. So you should use the equation where Cl2 plus 3 minus give to Cl minus, inert is positive 1.36. For the case of iron, you use Fe2 plus give Fe3 plus E minus, inert is negative 0.77. So your overall equation will be Cl2 plus 2Fe2 plus give to Fe3 plus 2Cl minus. So inert cell is positive 0.29 volt. So since the inert cell is positive, reaction is spontaneous. Excuse me. And then for the iodine, okay, so I2 plus 3 minus give to I minus, so inert is positive 0.54. So Fe2 plus give Fe3 plus E minus, inert is negative 0.77. So your inert cell will be negative 0.53, sorry, negative 0.23. Sorry for that. 23. So since inert cell is negative, reaction is non-spontaneous. So this is how you are going to make use of the inert values to deduce the spontaneity of chemical reactions, whether a reaction can take place or not. Okay, so you must be very good in knowing what are the suitable half equation to be used to compare for each of the circumstances here. Okay, so with that, that is for number 3A. Then we are going to go to 3b. Iodine and chlorine both react with sodium thiosulfate using different strength of oxidizing agent. So using suitable equation with the oxidation state mentioned, explain the strength of chlorine and iodine with sodium thiosulfate. So chlorine oxidized S2O3 according to the equation, where you have S2O3 2 minus plus 5H2O plus 4Cl minus give 2 SO4 2 minus plus 8Cl minus plus 10H plus. So this one, if you still remember of how we propose the reaction when we have Cl2 plus give 2Cl minus, and then how S2O3 2 minus become SO4 2 minus. Okay, plus how many E minus? If you still remember well of how to balance ionic equation when we learned in chapter 2 last time, so you should be able to get this overall equation. Okay. Okay, so in here, the chlorine are able to oxidize the thiosulfate to the highest oxidation state when the sulfur changes from +2 to become +6. Okay. However, for the case of the iodine, so iodine can also oxidize the thiosulfate according to the following equation, where you have 2 S2O3 2 minus plus I2 give S4O6 2 minus plus 2I minus. So this one is a very specific equations that you have to try your best to remember. And this is very, very common equation. Why? Because the how much iodine content react with the sodium thiosulfate will later test with the what we so call as the what we call it starch solution. Okay, because in starch solution, when I2 meet with starch, you will form a dark blue complex. So once the dark blue complex is not formed, will remain as the yellow color. That means the iodine has reacted completely. Okay, so the oxidation state of sulfur actually changes from +2 to +2.5 here. Okay, it is a milder oxidizing agent compared to chlorine. Okay, because it does not oxidize to the sulfur to the highest oxidation states here, unlike the chlorine. Okay, so that is how you are going to remember for this one. And these equations, you have to try your best to learn on how to balance it if you react with the chlorine. And for the case of iodine, this is a very specific equation, so you have to memorize a little bit on your own. Okay. Okay, so with that, that is how you are going to answer for essay question number 4. Okay. So you have to also mention chlorine is a stronger oxidizing agent than iodine. Okay. Okay, so then we are going to continue with question number 4. Hydrogen halide are observed as white fume and is used as a tear gas bomb in order to control the riot. When sparked with hydrogen, chlorine reacts explosively and completely, while iodine reacts slowly and reaches equilibrium. By using bonding and structure, explain the above observation and write the equation for the reaction take place in here. Okay, so you have to generally write the equations where you have the H2 plus Cl2 or I2 plus Cl2. So you have to write for both of them if possible. And the question already said that they are reversible. Right? So you have to use the reversible signs in here. Okay. So in here, we are going to talk about the stability of the hydrogen iodide, because if the stability of the chemical covalent bond, as I already mentioned again and again, that the factors that will influence the thermal stability of the hydrogen iodide or hydrogen halide, HX. First, because we are breaking covalent bond. So when we are talking about breaking covalent bond, the first factor, the primary factor will be the atomic radius. So when you have a larger atomic radius, bond length increase, bond strength decrease. Okay, so I hope that you'll be able to make use of this point to explain as fully as you can on how will the stability of this hydrogen halide take place, or how is it that they are going to react accordingly. Okay. Okay, so this is how we are going to explain this observation. Of course, hydrogen halide is already telling you that it is a white fume, so you don't need to repeat the statement again. Okay, so that is for number 4A. And then we go to 4B. Hydrogen chloride can be prepared by reacting chloride salt with concentrated sulfuric acid, but not hydrogen bromide and hydrogen iodide. 1. explain with suitable equation the statement above. Okay. So sulfuric acid act as a Bronson-Lowry acid first, where your Cl minus give plus H2SO4 give HCl plus HSO4 minus. Whereas H2, since H2SO4 is a stronger oxidizing agent compared to than bromine iodine, you have to express both of them. Yet it is a weaker oxidizing agent than chlorine. So that is why H2SO4 is not able to further oxidize chloride ion HCl to become Cl2. However, when react with the bromine ion and iodide ion, they are able to act as an oxidizing agent. Okay, so where the HBr and Hi are further oxidized by the H2SO4 according to the two equations that I highlighted here, where you have 2 HBr plus H2SO4 give Br2 plus SO2 plus 2 H2O, whereas for iodine, you are going to have 8 Hi plus H2SO4 give 4I2 plus H2S plus 4H2O. Okay, so this is how we are going to explain why is it that the sulfuric acid can further react with the hydrogen bromide iodide, but not hydrogen chloride. Okay, number 2, a possible method of preparing hydrogen iodide is to add water with a mixture of red phosphorus and iodine, then warm gently. Explain with suitable equation how hydrogen iodide is prepared. So first, you have to react phosphorus with the iodine to form the phosphorus iodide. Okay, so according to the equation, P4 plus 6I minus K4 PI3. Teacher, can I write as the simple P plus 4P? 6I2 give a 4PI3. Of course you can. Okay. If you want, this is not 4. Actually, you should use 2 is enough. 2, 3, 2. Okay, not necessarily have to use P4. Okay. Okay, then what happened next is it undergo hydrolysis in water. It undergo hydrolysis in water according to the equation. PI3 plus 3H2O give 3Hi plus H3PO4. And then why using this method you can prepare hydrogen iodide? Because H3PO3 is not a strong oxidizing agent. Okay, therefore will not further oxidize the hydrogen iodide. Okay, it will not further oxidize the hydrogen iodide in here. Okay, so this is the methods of how we actually prepare hydrogen bromide and hydrogen iodide in industry. So you use the hydrolysis of the phosphorus salt in here. Okay. So with that, that is for question number 4. Realization, let's advance to essay question number 5. So essay question number 5, here we go. Describe what we observe when chlorine water is added to aqueous sodium bromide. So include all an ionic equation for the reaction take place. So you have to state so colorless solution turns brown. Chlorine is chlorine is pale yellow. Sorry for that. Chlorine is pale yellow in this one. Pale yellow. Sorry for that. Chlorine in aqueous solution is pale yellow. Okay, so pale yellow solutions turns brown. According to the equation, Cl2 plus 2Br minus give Br2 plus 2Cl minus. Okay, and then B, identify 3 different chlorine-containing substances in everyday or in industrial use and state 1 uses for each of the substances mentioned. Suggest how the use depend on the relevant properties of the substance. So you can use NaClO or HClO is used as a bleaching agent. So DDT is used as insecticide because it contains many chlorine. This one, try your best to write as fully as you can due to the presence of the OCl minus. So this one, DDT is an insecticide because contain high chlorine compound. Percentage of chlorine, and NaClO3 is used as a herbicide also because of the same reason. Okay, so NaCl is a table salt because it is neutral. CCl4 is an organic solvent because it is what we so call as a non-polar molecule. Okay, and then CaCl3 is used as the anesthetic last time. Okay, so any 3 of the pair in here, okay, we will give you the 6 marks in here. Okay, very straightforward application. So try your best to at least remember some of the basic applications of the chlorine containing compound, because we have actually quite a lot Okay, you can also say that NaClO3 is also used as the bleaching in the paper, bleaching in the white paper. Yes. Okay. Okay, so with that, that is for question number 5A and 5B. Okay, so then we are going to go to 5C. When aqueous solution containing sodium hydroxide and sodium bromide is treated with chlorine, bromide ion are oxidized to bromine containing oxy anion. Careful addition of the aqueous silver nitrate to the resulting solution give 4.31 of silver chloride precipitate. This precipitate is then filtered off and more aqueous silver nitrate is added, which produces 1.18 of cream solid. So the cream solid in here is actually referring to silver iodide. You have to silver bromide. Sorry, you have to know by yourself about this with the following composition by mass. Oh, okay, sorry. Then it's not only silver bromide because it contains this mass. Okay, so what is the formula of the cream solid in here? So in here you have to deduce the empirical formula for this. So you use the empirical formula calculation method. So you have Ag, Br, and O with that percentage. Okay, so you divide by the mole. First mark is for 1 mole. Second mark is for the formula of the cream, which is AgBrO3. Number 2, how many mole of the cream solid and silver chloride are formed? So you have to divide by the RAM. Okay, so 1.18 divided by 235.9, you get 5.00 times 10 power of -3. For the case of the silver chloride, you have 4.31 divided by 143, you get 0.0300 mole. Okay. Okay, and then last but not least, hence write a balance equation for the chlorine and sodium bromide and sodium hydroxide. So in here, you should know that the ratio of the BrO3 minus to Cl minus is 5.00 times 10 power of -3 to 0.003. So you get 1 to 6. So if you want to balance your equation, you must make sure that between the chlorine and the silver bromide, you must have the ratio of 1 to 6 in here. Okay, so this question are trying to guide you on how to write these equations at the end of the day. Okay. Okay. So with that, that is how you are going to write for the balance equations for these reactions in here. Okay. So hopefully you are able to figure out on how to solve this kind of question when the right times comes. Okay. So this is how you are going to solve for question number 5. Okay, so hopefully you can understand this, and we continue to our final essay question, which is essay question number 6. Okay, question number 6 sounds like this. A halogen X and hydrogen gas when heated in the presence of a platinum as catalyst to form HX. So when HX dissolved in water, an aqueous solution is formed. When silver nitrate is added to the solution, a colored precipitate insoluble in excess ammonia is formed. 1. Identify halogen and explain your answer using suitable equations. So these are trying to tell you, especially when they specifically mention platinum as a catalyst, they're trying to tell you that X in here is the iodine. Okay. Okay, so here definitely I2 is iodine. Okay, then you have to write the equation. I2 plus H2 give 2H. Inside here you have a few equations. You have the reaction with the hydrogen, number 1. And then number 2, aqueous silver nitrate. Okay, and then number 3, insoluble in excess ammonia. So you have to explain these 3. Okay, okay. So since hydrogen iodide is a strong acid, it dissociate completely in water to form H plus and I minus. So I minus will then further react with the silver ion to form silver iodide, which is yellow precipitate. So the question didn't mention that. So you have to mention the yellow precipitate because the question only said color precipitate. Okay, the question only said color precipitate. So you must mention what color is that. Okay, so AgI cannot form complex ion with the NH3. So this one also you have to mention. Okay, so with that, that is all for the 6 point that you need to mention for number 1. And number 2, halogen X dissolved in aqueous KX solution in tetrachloromethane. So using suitable equation, explain the observation of the reaction above. So iodine dissolved in Ki to form the brown solutions. Okay. So you have to mention explain the observation. So you have to first mention iodine dissolved in potassium iodide to form a brown solution. So iodine dissolved in trichloromethane to form the purple solution. So these are the equations. So I minus plus I2 give I3 minus inside the iodine in potassium iodide. Okay, so and then because iodine is a non-polar molecule, so iodine dissolve more readily inside this organic solvent tetrachloromethane. Okay, so that is how you form the purple solutions inside there. Okay, so that is for 6A2. Okay, can. So we go to the next ones. 6B. Solid halide react with concentrated sulfuric acid to form HX gas, which then oxidize to X2 gas. The solid play an important role in black-white photography. So identify the solid halide and explain your answer. So they are trying to tell you that it's silver bromide. Okay, so concentrated sulfuric acid act as an acid in the first place, where you have Br minus plus H2SO4 give HBr plus HSO42 minus. And then bromide ion is oxidized by concentrated sulfuric acid to form bromine. So HBr plus H2SO4 give Br2 plus SO2 plus 2H2O. And then in black-white photography, so silver bromide, when you act under UV, you form silver and bromine. So all these are trying to lead to you, trying to tell you that the X in here is silver bromide. Okay? Especially when the questions specifically mention that it plays role in the black-white photography. So you have to automatically know by yourself that it is a silver bromide that they're talking about. Okay. Okay, so with that, that is all for the explanation for the essay questions that I have for you today. So with that, that is all for chapter 6. So tomorrow we are going to continue with the final chapter for this semester 2, where we are going to continue with chapter 7. Okay, so with that, I end my lesson for today. Okay.